Hi guys, I'm Arvind, and this week my presentation is on the article titled Evolutionary Perspectives on Health and Medicines by Stearns et al. Before I get into the presentation, I will say that in this article, much of the evolution in medicine is intertwined. The purpose of this article was to highlight this intersection, and because of this, there is not much separation between the two, at least in this article. For this reason, I will be highlighting the themes of this intersection and the insights that have arisen because of it. We sometimes have a predisposed view of evolution and its applicability. For me at least, when I think of evolution, I tend to think of a phylogenetic tree and predator-prey relationships. While these things are very important and have helped us to better understand the world that we live in, evolution can be even more applicable if we broaden our view on it. This is especially true when we discuss evolution's role in shaping humanity. Whether we like to believe it or not, the same selection processes that act on every other organism on the planet also act on us and our own relationships with pathogens and with the environment. On that end, we currently find ourselves in a co-evolutionary arms race similar to that of brood parasites and cuckoos. While it may not be pleasant to think about, understanding these relations will improve the way in which we treat patients and will lead to the progression of medicine. It does require us to change the ways in which we think about disease, and especially in the case of environment, change the ways in which we live, which will be difficult. The good news is that this work is already being done, as I will show in the upcoming slides. The first of these insights, mentioned in the paper, was the idea that we maximize reproduction over health. The idea of natural selection corroborates this idea, and it makes sense. Having more viable offspring maximizes the advancement of our own genes into the future generations. In our lives, we have grown accustomed to comfort, and this is especially true in terms of our health. We think of healthy individuals as those who don't have ailments, rather than those who have a lot of children. This position that we are in requires a change in the way that we look at some diseases. In class, we talked about breast cancer and its prevalence in society. It was observed that women who carry the genes linked to breast cancer, on average, have more children. We can then see why these genes would continue to be passed on from generation to generation. In the paper, an example mentioned was the question of why we age. Aging doesn't seem like something that would be advantageous, but what the authors go on to point out is that aging is just a symptom of having higher reproductive ability earlier on in life. While aging is not pleasant, it is the result of being able to pass on our genes at a higher rate and more effectively, and is thus something that we will have to deal with. The second theme the article mentions is one that I believe may have the most immediate impact on our lives. It states that there is a mismatch between our body and the environment which we have created for ourselves. This mismatch, in turn, may lead to many diseases. There are a ton of examples to support this. The easiest one for me to think of, and one that was mentioned in the paper, is smoking. Smoking is obviously not something our body is well adapted to, and in turn, it has been linked to lung cancer and various other diseases. Another mismatch that is mentioned is our diet. This may apply more to the United States than other countries, but the fattier diet that we eat is also not well suited to our bodies. This causes issues like obesity that are running rampant through our society. The use of contraceptive have also created some issues. They have been shown to increase the risk of reproductive cancers as well as cardiovascular complications, further highlighting the ways in which our unique lifestyle, at least amongst living organisms, can affect our health. As I'll go over in the next slide, we are constantly changing and adapting to our abiotic and biotic environment. However, our lifestyle changes have progressed much faster than our bodies can react. This causes uncertainty in how these changes affect us, and in many cases, these changes can have unintended and sometimes serious consequences on our health. I mentioned previously that we are under the process of natural selection, whether we like to believe it or not. This is perhaps the clearest when we discuss our relationship with pathogens. We are in a constant race against them and the diseases that they cause, yet throughout the course of human history, we have consistently come out on the losing side. This sad state of affairs is not likely to change because of the fact that pathogens evolve quicker than us. Whether it be because of their overwhelmingly large numbers or their shorter generation time, the fact is that they are always one step ahead. This is seen in numerous cases, but perhaps most prominently in antibiotic resistance. It is very difficult, if not impossible, to create a 100% effective antibiotic. The sad truth is that the bacteria that are able to survive the antibiotic will lead to a host of more bacteria that are also resistant to the antibiotic, rendering it not only ineffective against the strain, but also creating a new resistant bug that we must now worry about. The problem is not just seen in antibiotics. Vaccines that fail to eliminate all pathogens can actually increase the virulence of the virus that they are intended to treat. Both of these problems shed light on the losing battle that we find ourselves in, making disease inevitable. But if there is any silver lining to this problem, it is that we can understand the ways in which these pathogens evolve. From rapidly mutating RNA viruses, we can and have gathered a wealth of genomic data that we can use to hopefully predict new mutations and strains, as well as study patterns in the previous ones. The future hope is that this data can help us treat and hopefully stop some of the diseases that currently plague us. A lot of this paper focuses on the idea that the intersection between evolution and medicine leads to insights that go against the conventional grain of thinking. This is particularly true of the last insight or theme of this paper, which is the idea that disease is not caused by faulty genes. While it is true that genetics do play a role in some diseases, that view is not broad enough. Instead, disease is caused by the interaction of multiple factors, genetics for sure, but also the environment and other complicated factors. In an interesting example shared by the authors of this paper, it is theorized that some mental illnesses may be caused by disruptions in imprinting. In the wild, such an idea is not hard to believe. It makes sense that both parents take an interest in their offspring and want them to express their respective genes, an idea known as the evolutionary tug of war. While it may not be as obvious, similar forces are at play in humans. Whether by mutation or a developmental event, when this natural 50-50 split of mother and father is disrupted, it can lead to a different phenotype than expected in the offspring. The paper mentions that in the case where the mother is overrepresented, the child may be at higher risk of psychosis. Alternatively, in the case where the father's interests are overrepresented, the child may be at higher risk of autism. A seesaw is a good model for this, where one side being unrestricted, which in this case looks like an unbalanced seesaw, may lead to issues for the child later on in life. It is also another example that we are under the same evolutionary constraints as other organisms, and by taking that into account, we can hopefully better understand our own ailments. Sadly, as with many things in our society, the issues brought up in this paper do not affect all people equally. Some groups of people are at a higher risk for the issues presented. First, the issues with contraceptives, which may lead to reproductive cancers and cardiovascular issues, affect women. One thing for certain is that the lifestyle that we live now is unlikely to change, at least in the near future. So, a possible solution in this situation would have to involve looking at both sides of contraceptives, which in this case would be to increase the use of current contraceptive methods like condoms, and also to look into more options for men to alleviate the pressures on women. Another situation described in the paper that leads to unequal outcomes is a situation that was described on the previous slide. There's support for the idea that developmental events related to imprinting may lead to issues later on in an individual's life. This puts those who are not in two-parent households at a greater risk for these problems. To try and rectify this, an increase in accessibility to childcare and more research into imprinting and its effect on children are necessary. The final one I will go over, but far from the last example of inequitable outcomes, is the issue of imperfect vaccines. The paper mentioned the malaria vaccine in particular as being imperfect. Malaria is predominantly found in large areas of Africa and Asia, putting the people that live there at a significantly higher risk for the issues caused by malaria, as well as the issues caused by the imperfect vaccine. The simple solution would be just to create a new vaccine, this time preferably one that doesn't allow for pathogens to escape. However, this has several issues. First, creating such a vaccine is very hard, and especially now if the disease is more virulent. Second, after one vaccine, those taking it may be skeptical of taking another. Transparency in the process of creating the new vaccine can help the skepticism, and an effort to help from areas that may not be as affected by malaria would also help to support a more equitable outcome. With this new perspective on the way that we view disease and how we can treat it comes changes to our system to better support this view. Much of the burden will fall on those that hope to go into a career in healthcare, which will be us. Sadly, this may mean adding more to an already heavy course curriculum. Also, as was mentioned in the paper, natural selection does not act on genotypes, but rather phenotypes. Thus, a broader study into phenomics can be helpful in understanding evolution and its effects on our health. Finally, much data and research is already done. Simple lifestyle changes can go and make a large difference in our health, especially when done at a population level. This doesn't mean that we have to completely change the ways that we live, but to understand that what we are doing may not be in our best interests. Thank you for listening to my presentation.